So hello everyone. Today we'll be seeing one of the problem from Geeks for Geeks. It says sort zeros, ones and twos. It's very similar problem or exactly equal problem to what we had in lead code, known as sort colors. You can see over here, it's exactly same. So the problem is pretty much simple. We provided an array with which will contains 0, 1 and 2's only, and we wanted to sort it. One thing is that you can go ahead and sort it as a regular array, but that's not very efficient because you're not using the fact that array contains only 3 elements. One thing is that you can store count of 0, count of 1 and count of 2, so that you can just create an just override the array or create a new array for that matter with 0 2 times initially, 1 2 times initially and 2 2 times initially based on their counts. But yeah, we don't want it to do that as well, because follow-up of this is, could you come up with one pass algorithm using only constant extra space? Although if we are having 3 so count is still 3, which is again an extra space of constant, but we don't even want to use that constant space. So the idea behind this is, instead of storing these 3 counts, 1 2 and 0, 0 1 and 2, what can we do to do it in single pass? And I'll tell you beyond this point as well. This is why this is important. It is important to understand the streaming data. So if the data is streaming in continuous bits, you don't know what the next data would come. So 0 1 1 1 1, we have 2 2 2 2, you have 2 2 2 2 2 2 2, then you have 0 0 0 0 1 1 1 1, 0 1 0 1 0 1 and 2 2. So in such a fashion. So these are just a random numbers I have write it over here. So at one point you will get 2, then you will get 0, and on the fly you wanted to understand, hey, I got a 0, what should I do? Because let's assume a video streaming platform, something like that, and now you wanted to sort this bit in such a way. You cannot predict what things would be beyond, because right now you just have 0 and you wanted to take it and put it into the right place, put it in right place. So this word is very important, put it in right place. So what does place mean here? Like, what is right place first of all? So place means an insertion point. Place is equal to an insertion point, and right place is a right insertion point. And as you can see, we have 3 numbers, so there would be 3 right insertion points. But can we outsmart this one? Yeah, we can obviously outsmart this one. Not 3 but 2 right insertion points. So we'll design a system, or we'll design an array in such a way, or insertion point in such a way, we would have zeros, and here is zeros insertion point and point. Then we would have some numbers, and it is 2's insertion point. So this would be something like our array would look like. If you can visualize it, it's very good. And we can have further elements over here. So this is what our array could look like, and we have 0 insertion point, 2 insertion point and 3. So let's assume our this number can be anything. So I'll tell it at x is equal to 0. So if x is 0, insert in 0's insertion point, and similarly 1, then do what? We'll come to that. But if it is 2, insert in 2's insertion point. While doing this, we are sure that, hey, within this array, we are sure that beyond 2's insertion point, we have 2's only, and previous to 0's insertion point, we have 0 only, provided this array is sorted. And likewise, we are dealing with sorted array, we are keeping the sorted array sorted upon every insertion, the resultant outcome would be a sorted array itself. But now what about 1? Where we are going to insert it? We are going to insert this 1 next to 0. Yeah, that's cool. Because we are traveling from left to right, next to 0 means 1 itself. So here would be zeros, this is a 0 insertion point, and here would be 1s, and here would be 2. So far so good. This seems very excellent. Let's see how it would work. So I have zeros. I'll go one by one. I'll have first 0 here, 0, then 0, then 0. Right now a 0 insertion point is this only, start. We have 1 next to 0 insertion point. So this is a 0 insertion point. I'll mark it over here. Then we have 1, 1. Now we have 0. Where do I keep it? I'll take this out. I'll keep it 0 over here. And I'll create an insertion point over here. And next one is coming here. So likewise, I have picked that, put it into the 0's insertion point, and mind that 0's insertion point was like this earlier. Now it became like this. So 0's insertion point has incremented. And similarly, I'll do it with 2, but in the reverse fashion, it would be decrementing, because 2, initially 2's insertion point is like this, and if any 2 appears, it would be like this. Initially nothing was here, so I'll tell null, and here is 2. Cool, we are going to do it in place. No need to return anything. I'll just have 2 variables, set z and t, and one iterator I, whereas z is equal to 0, t is equal to z is 0's insertion point, zi, ti, and I is just iterator. Zi is equal to 0, ti is equal to a dot length minus 1, because that's the last valid index, and you know that 2 is the maximum value, it would go in last. And while I'm dealing with I is less than ti, less than or equal to ti, I'll do. And I, what is I? I is just iterator. I is equal to 0. It will iterate from 0 till the last valid index. Cool. Now we have x, which is a of I. What we can do is switch to x. We have only 3 cases. Case is like, it can be 0, case 1, it can be 1, and there can be case 2. Break. There, if you want, you can write default case that hey, the array is invalid. Now we will do these operations 0, 1 and 2. When it is 0, insert in 0's insertion point. Cool, nothing fancy. Insert in 0's insertion point. I would insert it by swapping the values from a, from 0's insertion point, to I, from I, and I'll do zi plus plus and I plus plus. Cool, because I have already inserted the 0's insertion point, and the next insertion point would not be 3 but on 4. Cool. I would write swap method in the end, so no need to worry about that. So case 2, insert 2. If we got 2, insert in 2's insertion point. Nice. Now I'll swap with a, zi, sorry, not 2's insertion point, and current iterator. I wanted to ti minus minus, because the 2's would be increasing, and it would go from 0, having 0 as count, to 1 as count. That means earlier it was a dot length minus 1. Now it is a dot length minus 2. So from this it would go into the reverse direction, a dot length minus 2. Do I want it to do I plus plus? That's a question. That's a very good question, by the way. No, I don't want it to do, because you see, I plus plus I do when I'm sure that ith element is processed. But now when I'm swapping this one, the t'ith element would come at ith position. I repeat, the t'ith element which was at this position let's say this position would come to our current position, ith position, wherever you are, I. So I can be here, I can be here, anywhere. So it would come to at that position, and we don't want that, because we have not processed the tith element. So we'll keep it as it is. We will not increment ith pointer. And this case 1, what if we hit 1? So yeah, if we hit 1, let the 1 be as it is, because it is where it is supposed to be. Why? Because we have 0 insertion point, we have 1 insertion point, and between them I am running for I is going here, 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 but within the limits of ti. It would never cross the boundary of ti. So where I is 1, it's in the safest place, because I want all the ones to be in middle of 0 insertion point and 2 insertion point. Remember this point: 0 insertion point, 2 insertion point. I want all the ones to be in middle, and yes, it is in middle, so it's a good case for us. So just I++. I'll quickly go ahead and write swap method. Bear with me, it's very simple. Void swap int a int x int y. I'll take t with a of x, and a of x would be t, a of y, and a of y would be t. Classic swap. Let's try to compile this one. Yeah, it compiles well. Compilation completed. Let's try to run this one. Run for rest all the test cases, and I think it will pass all the test cases. Yeah, it does. So this was a classic problem involving array and sorting mechanism. As you can see, this has been asked in multiple company interviews. So this is one of the classic and standard problem when it comes to judging your basic algorithm sense. The expected complexity, we respect them, and we had achieved. Topic tags are array sortings. For more such array and sorting related content, click the video on your right, and as usual, I'll see you in the next one.